Hello, we're Group 20 from ECSE 399 and our project is WAAM 3D printer and will be mainly focused on the electrical side of our project. Our advisor is Professor John Lewandowski. My name is Boshun with my teammates Tian Li. Nowadays, 3D printing has been a fast developed technology, and the essential process is called wire arc additive manufacturing process, represented by WAAM, which is a technology of depositing metals layer on top of each other. And there are lots of great structures created by this technology. However, in order to make such great 3D structures using 3D printer, currently the market are using costly machines and requires all the people that operate the machine with experiences. Thus, we want to design and develop a modular 3D printer with open source control that is more easily adaptable for research environment. In order to build the 3D printer, we separate to mechanical team and electrical team. Mechanical team will be mainly in charge of building the frame for 3D printer, and electrical team will be mainly in charge of wiring and program the system. For our project, we'll be mainly using the Marlin Arduino code to program the control board and using the interface to control the motion of the motors. One of the standards we used is the ISO ASTM 52900, which is the Additive Manufacturing General Principles Fundamental and Vocabulary. It is the standard that helps us to understand how WAAM technology works, which potentially help us to understand how 3D printer works. Here is the CAD model that built by the mechanical team, and there will be one motor on the X and Y axis and two motors on the Z axis to make the 3D printer work.
To achieve the printing movement, we use 4 stepper motors to locate the welding needles, one for X-axis and one for Y-axis and 2 for the Z directions to lift up and down. We choose NEMA 23 stepper motors based on its reliability and high accuracy. Also, this stepper motor perfectly fits the function of our board, Do It 3D. Do It 3D control board is an advanced 3D printer control board that widely used in the industry. It is a well-functional board that supports stepper drivers, thermistors, fans on the main board. And to explore new functions, we can buy an expansion board if needed. RepRap firmware is used in Do It 3D control board. This firmware is pre-compiled and configured on SD card, plugged into the control board. G-code can be received by connecting the Ethernet interface for operation. Using software yet, we can talk to the board. Our instruction or command can be delivered using G-code. For example, M552 is to enable the network connection, and G28 is to home all the access. Configuration file is the key in the 3D printer setup. Not like other control boards that we have to program the code for configuration, the Do It configuration file can be automatically generated online when we know the functions that we will use and the information of our parts. After we get the configuration file, we simply upload it into the control board by using Do It Web Control. From there, we have completed all the setup for our 3D printer. For our project, the overall success criteria is to finish building the 3D printer and successfully print one testing model. And for our electrical team, our goal is to make sure all motors work functionally and connect the electrical components on the finished frame. Currently, the mechanical team is still busy building the frame, so we will only do a brief demonstration of the setup of the testing board and motors.
Here is our setup for the testing board. Here we have the power supply, and here is our testing control board which connected to the 3 testing motors. Firstly, we compiled our code in Marlin and make sure the code works functionally. And secondly, we upload the Marlin configuration file to the board. And thirdly, we connected to the printer face and finished the setup. Now, after we finish the setup now, the motors can move functionally as you can see. And in the future, if we have a 3D printing file, the file will be uploaded to Pronterface and motors will be moving based on the CAD model.
Here is a brief demonstration of our electronic part, and because we are still waiting for our NEMA 23 stepper motor which matches our DUIT control board, we are currently showing another easy range control board in the video which has the same functionality. Once our mechanical team finishes the frame, we can put our stepper motors on and it should work functionally. Currently at the first stage of our project, we have completed the board setup and basic function. For future teams, they can extend the project with different welding methods and using other material for this project.